Morning, sir.
Yeah, good morning all. So good morning to you all. Hope I am audible to you. If you have any audio issue, please write that on chat.
Yes, sir, you're audible.
Okay, thank you. So we'll start in a few more minutes. We'll wait for some more participants to join in.
Good morning, sir.
Yeah, very good morning. So in the meantime, if you have any doubts from the previous classes, you may ask either in the chat box or you may unmute and ask if you have any doubts.
Good morning, sir.
Yeah, very good morning. Let us wait for one more minute.
Okay.
There are still participants joining in. So in the meantime, if you have any doubts, kindly write that on the chat box or you can directly ask.
Okay, sir. Sir, yesterday you told one problem, right, sir? 4-digit multiplication. Can you explain?
Good morning, sir.
Yeah, so
Good morning, sir.
yeah, very good morning.
Good morning.
So regarding the 4-digit multiplication, we'll talk in today's lecture. You will learn how to do 4-digit multiplication after hearing today's lecture. So you have to wait till today's lecture gets over.
Good morning, sir.
Yeah, very good morning.
Good
Very good morning to you all. So hope I am audible to you all. If anybody has any issue with hearing the audio, kindly put that in the chat box. Okay. Right. So I'll just give you some warm up before we start the recording for the YouTube. So I'll just revise through what we had gone through in the last class. So in yesterday's class, we were talking about special multiplication. In special multiplication, we saw how we can do numbers close to the base. And we learned some special numbers, just like 37 into 3. This is a very special number. What was this? This is 111. So if you learn some of these special numbers, then you can do multiplication much more faster. Now, in today's class, we are going to learn about a general rule for multiplication. This is called as general multiplication. And here we'll see a kind of shortcut which is termed as vertically and crosswise. So that is the name of the lecture also, vertically and crosswise. I'll explain more as we proceed in this lecture. So before I just begin, Lakshman sir, can I start with the lecture?
You please.
Good morning, sir.
Yeah, very good morning. So from this point of time, I'm going to mute you all. Please write your questions in the chat box. I'll be looking into the chat box. Okay. So let us begin with this lecture name. It is called as vertically and crosswise. And what we are going to see is general multiplication. So we begin with some puzzle. Every day we start up with some puzzle. So today is a very interesting puzzle, which is a continuation of the puzzle that was given as homework to you yesterday. So let us see what is the puzzle. Yeah, so the question itself here is, what's your favorite puzzle? So there is a boy whose name is Alex, and he opens his favorite mathematics puzzle book. And he notes the page number, and he sees that the product of the page number are 1332. Now, a question comes to the mind of Alex, whether it is possible to find the sum of these two pages. So you have to help me with this answer. How do we do this particular operation of summing up the numbers? So we are unaware of these two numbers which have been multiplied, but it appears on the leaves of the book. So if you open a book, for instance, let me just try this out. Okay, so if you open the book like this, two pages appear, isn't it? There is a page number X. So the page number next to it, it will be X plus 1. So the number we are looking at are what are known as consecutive numbers. So now you will be given a chance to see how we are going to solve it. Unfortunately, I'm unable to see the chat box. Let me just think. The host, could you just help me with seeing the chat box? I'm unable to see the chat box. Okay, yeah, I think I got it. Okay, so can you just figure out what is the procedure to see what are the numbers to be multiplied to get 1332? Anybody in the chat box? Yes. So the procedure to apply is what is called as prime factorization. We are going to find the prime factors of this number 1332. So we are going to express this as 2 times some number. What is that number? 2 times 666. Because we see that 666 multiplied by 2 is nothing but 1200 plus 66 times 2. 66 times 2 is 132. So this can be again factorized as what? 6 times 111. Now here is that magic number 111 that appeared. So this is equivalent to writing 2 into 6. We know this magic number is formed as 37 times 3. Now let us combine all the prime factors. Here there is a 2 and there is a 2 in 6 as well. So this will be 2 squared into 3 squared into 37. Now clearly 2 squared times 3 squared is what? 36. So what we are looking for is the sum of the consecutive page numbers. So we have got a consecutive pair, 36 and 37. So the page number here is 36 and the page number here is 37. So what is the sum of 36 and 37? Yes, I think few of them have written that in the chat box. It is 73. Okay, so let me have a look into the chat box once again. Okay, so some of the students have got it right. Maunika and Pavana. Okay, so let us just proceed further. We will learn about this new method for doing general multiplication. So before we start learning that, we have to introduce a few notations. So I'll First of all, do a simple problem like 74 into 8. This is a 2-digit number multiplied by a single-digit number. So the steps for doing this are very clear. Many of you might know. We can do 7 times 8 and 4 times 8. 7 times 8 is 56 and 4 times 8 is 32. Now in the Vedic mathematics, we always prefer to go from left to right. What is the leftmost digit in 74? It is 7. That is why we did 7 times 8 first. The rightmost digit is 4, which is 4 times 8, 32. Now the notation that I want to bring is this comma. So you represent these numbers 56 and 32 separated by this comma. And since this is a base 10 and 100 multiplication, what we should do is that combine the last digit of the rightmost entry with the units digit of the leftmost entry. So you have to do 6 plus 3. So 6 plus 3 is 9. So the answer has to be 592. So this is how you usually do the carry operation in usual multiplication. Let us do one more of this sort so that we can understand the notation a little bit more carefully. So for doing 827 times 3, we do 8 times 3, the leftmost entry, then the middle entry, which is 2 into 3, which is 6, and then the last entry, which is 7 into 3, 21. Now we are going to write the first two entries. What are they? 24 and 6. So we write 246, where 4 and 6 have a comma in between. Now here we need not do any addition because this is a single digit number. You need not worry about that. Now in the next step, we combine 246 with 21, but then 21 here is a 2-digit number. So you will have to do this addition of 6 plus 2. So that will result in the answer 2481. So I think the notations are clear to you now. Yes, I can see Suhas has given the answer. So keep posting the answers as far as possible so that you become engaged in the lecture. So let us go to the next process, which is specifically to see 2-digit numbers or 2-figure numbers. We'll take up this example of 21 plus 23. Now we know how to solve for 21 into 23 from yesterday's lecture. 21 is 1 more than the base of 20 and 23 is 3 more. So the answer should be 3 over here, and the remaining you can do as cross addition, which is 24, and you have to multiply by the factor of the local base, which is 2. So the answer is going to be 483. Now let us figure how to do this while doing general multiplication. So let us see what are the steps involved. So first we do vertically. So the method that we are going to learn is vertically and crosswise. So the first step is vertical step, where we multiply 2 times 2. What is the answer? It is 4. Now you do crosswise. In crosswise, you have to multiply 2 times 3 and 2 times 1 and add these up. So that will be 6 plus 2, which is 8. And the final step is to do again vertically, which is 3 times 1. So the answer is directly available to you, 483. So you need not go to the tedious steps of finding these, how much close to the base they are, and then multiplying by the base factor. Let us see one more example to make this idea concrete. What is 14 times 21? So we are going to do vertically and crosswise. So the vertical step says that you have to do 1 times 2. The answer is 2. Then we have to do crosswise. 1 times 1 plus 4 times 2. What is that? 9. And then the last step is what? Vertically. That is 4 times 1, which is 4. So the answer should be 294. Okay, I can see Maunika, Mahendra, Ashraf, Suhas has given the answer. Very good. But while you do these calculations, kindly try to learn this new method. Either apply the new method or the method that we have learned in this class. So I can see more answers from Guru Charan, Krish, Hassan, etc. So let us do one more sample exercise over here, which is to find how much close are these numbers to the base. So if we consider the base of 20, this is minus 6 from 20, and this is plus 1. So currently we have not seen examples where the numbers are less than the base and one of the numbers is greater than the base. So here is one such example. So the answer to this can be written as minus 6 times 1. What is minus 6 times 1? It is 6 bar. So that is the first part. Now you do cross addition. So 14 plus 1 is 15. But then you have to do multiplication by 2. So the answer is 306 bar. But we have learned that the notation 306 bar is equal to 294. So we are getting the same answer. And this is a verification step that we can do for vertically and crosswise. So let us move ahead further. So this is the procedure that we are applying. In the first step, we are doing a vertical multiplication of the digits. In the second step, we are doing a crosswise multiplication. And in the third step, we are doing again a vertical step. So I hope the method is clear to you all. Is it clear? Can you write Y in the chat box if the method is clear? Okay, Suhas is asking why we have multiplied 2 with 15. I'll just explain that, and Hitesh Sai has not understood, it seems. Okay, so I'll just explain this method once again. So first of all, let me explain this base multiplication method that we just learned yesterday. So base multiplication. So first step is to identify what is the base which is closest to 14 and 21. The base is 20. Everyone agrees on that? 14 and 21 are close to the multiple of 10, which is 20. Now this is called as a local base. Why is it a local base? Because the multiple is not like 10, 100, etc. This is an even number 2 multiplied by 10. So it is called as a local base. Now whenever you have a local base, you have to multiply this factor of 2 with the resultant cross addition. So you have to add 1. So let me just explain from the beginning. So 14 is minus 6 away from 20 and 21 is 1 more than 20. So the first part to the answer is minus 6 times 1, which is 6 bar. And then you have to do cross addition 14 plus 1 to get 15. But this answer would be true only if the base was true base. In our example, we have a local base, and that is the reason why you have to multiply by 2. So now it must be very clear. Now let me explain to you once again how we got this vertically and crosswise answer. So you look at this particular figure, which is explaining the method. So to get the highest place in this, the highest place is the hundreds place. To get the hundreds place, what you have to do is do a vertical multiplication of 1 and 2. To get the tens place, you have to do crosswise, which is 1 times 1 plus 2 times 4. 1 times 1 is 1, 2 times 4 is 8. So the sum is 9. That is the middle number. And then finally, to get the last place, the units place, you have to do 4 times 1, which is 4. So I hope the method is clear to you. Yeah. So is it clear? Yeah. Mahendra says it is very clear. Okay. So I'll just proceed. For students who are new to this class, don't worry. We'll have a lot of examples to learn this method. So let us go to the next method. This is a practice of what we have done, but this time try to do it mentally. So I'll look into the chat box for 15 seconds and I want all of you to answer this. What is 22 multiplied by 31? It's quite direct. Yeah, I can see some answers coming in. So let's do vertically and crosswise. I'll just write the answer down because this is a mental multiplication. So this is 6 and then 2 plus 6, which is 8, and this is 682. Yes, Suhas has answered, Ashraf, Maunika, Krish, Mahendra. I want others also to join the chats. Sanjana Charan, very good. You have also answered. Now let me move on to the next. 61 times 31. Again, you will get this time 10 seconds to answer. So this is 18. 6 plus 3 is 9, and 1 times 1 is 1. Yes, Suhas, Pavana, very good. You are all fastest fingers. Vikram, very good. Yashwant Reddy, Mahendra, Maunika, very good. So let us try 2 more of these practice. 31 squared. What do we do with this? 3 times 3, which is 9. The middle number is going to be 6. The other number is going to be 1. So how amazing is this? Isn't it? Let's try one last. This is also square. 13 squared. It is quite easy. 1, 6, 9. 13 square. We always know tables up to 20. Most students know the tables up to 20. So 13 squared is already known to you as 169. Now I want you to try what is 34 square. 34 times 34. We have done this yesterday, but let us apply vertically and crosswise. Here you will encounter a small difficulty. So I want all of you to try this. So the first number is going to be 9. The middle number is going to be 3 times 4 and 3 times 4, the summation of that. 3 times 4 is 12. So 12 plus 12 is 24. 24, we'll write it slightly differently. 2 as a subscript, 4 above. And then you'll get 16. 16 is also written differently. So the answer here is going to be 6 you'll write 1 plus 4, which is 5, and then 2 plus 9, which is 11. So yesterday we applied this method of closest to the base to get the same answer, 1156. And there was a problem also that we tried. What is the sum of digits for this 1156? So the answer came out to be 13. Yeah. So today we have learned basically a new method called as vertically and crosswise, which is for doing general multiplication. Now I'll just talk about a little bit on how we can make this carry multiplications much more easier. So when you get a carry, do not worry. First of all, calm down. When you get a carry, do not worry. So I'm going to teach you how to deal with carries more efficiently. So let us do 23 times 41. Let's do vertically, which is 8. Then crosswise, 2 plus 12, 14. Whenever you get a 2-digit number, you put the second digit as a subscript, like this. 14 is written as 1 in the subscript, 4 in the normal place. And the last digit is 3. So this answer is going to be 943. You have to add the subscript with the next number, which is 8. Yes, I can see a few of you have replied the answer. Vikram, Mahendra, Ashraf. So let us do one more of this kind to make this concept really strong. So we are going to do 23 times 34. Let's do vertically and crosswise. 2 times 3 is 6. In the middle we have 8 plus 9, which is 17. And the last is 12. So we have 2 carries here, just like the 34 square that we did earlier. The answer is going to be 782. What did we do? We added 1 to 7. We added this 1 to 6. The answer is 782. So very good. We can see a lot of answers coming in. Okay. Somebody has written 792. Kindly check that. The answer is 782. Okay. So let us do two more of this kind. 33 times 44 this time. What is 33 times 44? So the answer is 12. 12 plus 12 is 24 in the middle. And the last is again 12. So the answer is going to be 14, 5, 2. Yeah. So again, thanks to Jaya, Rani, Ashraf, Srihit, Sudeep. Very good. I can see many new names appearing. That is a very good sign. So I want all the students to be active in solving this question. Now we go to the last part in the practice, 53 times 84. So here we have 40, and then we do 20 plus 24, which is 44, and the last part is 12. The answer is going to be 4452. Still waiting for the answer. Hasini, Suhas, Vikram. Thank you for your answers. Now I'm going to do this particular problem, 33 times 44, in a slightly different manner. How do we do? We can write 33 as 11 times 3, and we know 11 is a magic number. So we can do 11 times 3 times 44. What is this number? 3 times 44 is nothing but 12. There is a 1 carry, then there is 132. So the answer is 132. Now, can we do 11 times 132? Yes, we have learned a technique yesterday, how to do 11 times 132. So let me just take a little bit space and do this on the top of the page here, 11 times 132. To do this multiplication, start from the left. You write the first number as it is, then sum up the two numbers, 1 and 3, to get the next place, which is 4. Then sum 3 and 2 to get 5. Again, last place is 2. So this is for all the new joinees. I can see many of you have joined for this class for the first time or have missed the last class. For them, the multiplication of 11 is explained again. So I can see a few students who have written, for example, Krishnam Sarita. Last I don't understand. So are you talking about 53 times 84? So Krishnam Sarita, if you did not understand 53 into 84, kindly write yes. Okay, yeah. So I'll explain 53 times 84 once again. So what we are going to do is vertically and crosswise. In this method, first you take the highest digit. This is the tens place. This is the tens place of the second number. You multiply these two. You will get 5 times 8, which is 40. Then for the next place, you have to do crosswise multiplication. You do 5 times 4 to get 20 and 8 times 3 to get 24. Now add 20 plus 24 to get 44. But 44, we are going to write it as 4 in the subscript and the units place 4 in the normal place. And the last step is to do 3 times 4, which is 12. 12 also is written differently, 1 in the subscript, 2 in the normal place. Now what you have to do is you have to consider these carries. 1 you have to add with 4 to get 5. 4 you have to add with 40 to get 44. So the answer is 4452. So hope it is now clear. Is it clear? Krishnam Sarita, is it clear? Okay. So if you have further questions, we can take up at the end of the lecture. Okay. We'll just proceed with a small break here where we will understand what is the relationship between mathematics and music. So I want to introduce this because if you just do a lot of problems without seeing the application of mathematics, it will be not of much use. You will do a lot of calculation, but you don't get a practical feel of where it is applied. Now I'm going to give you a specific example where all these mathematical concepts are going to fit into. And a lot of them are there in music, dance, and many other art forms, even in painting. So, what I'm going to talk to you in brief is about the Hemachandra sequence. Now, this name might be new to some of you, but there is another name for this. This is known as the Fibonacci sequence. Some of you might have heard about the Fibonacci numbers or the Fibonacci sequence. If you have heard about Fibonacci numbers, can you put Y in the chat box? If you have heard about the Fibonacci numbers, kindly put Y in the chat box. Yeah, Mahindra is saying no. Krishnam says no. So I think many of you are new to this number, Fibonacci sequence. So I'll just explain in brief what is it. So you begin with this number 0 and this number 1. So 0 is the least whole number. Yesterday we were talking about whole numbers. Whole number is a set of natural numbers plus 0. So first we get the number 0, then we write the number 1. Now what you have to do is do addition of 0 plus 1. You will get the next number as 1. So the addition will result in 1. Now again you take two adjacent numbers. In this case it is 1 again and 1 again. This you add to get 2. Again you take 1 and 2, add them up, you'll get 3. Now add 2 and 3 to get the number 5. Now I want all of you to try for the next number. What is the next number after 5? It is 8. Yes, Suhas, very good. The number is 8. So let us see. Now what comes after 8? 5 plus 8, which is 13. And this sequence goes on. Now there is a relationship between this sequence and the rhythm that we hear in music. So this particular number shows how many combinations you can make for creating a rhythm in music. So if you just hear some music piece, you can figure out how many kind of music patterns can I generate, and it is based on this sequence. Now I'll show you a video which will explain this. Hope I can share that video. Let me just try that out. So this video is an interview with a Fields Medal winner, Manjul Bhargava. This is a very exciting talk. So hope you enjoyed this particular video. So you can search for Manjul Bhargava. He's a very famous mathematician who has got the Fields Medal, and Fields Medal is considered to be like the Nobel Prize in mathematics. So let me just go back to our slide. So what he was talking about is about this Fibonacci sequence, which can be utilized to know how many laya patterns or how many rhythm patterns are available to make or compose music. So I can see a few raised hands. I would like to ask them to kindly wait till the end of the lecture, so that I'll just have some more time with you, so as to clear the answers. Okay, so let us go to the next part. So how is all this vertically and crosswise working? Is it more like a magic, or is there some science behind that, or is there some explanation that you can give? Now here is the explanation. So there is a connection that we can form. So let us take this particular picture to understand that. So the method that we are going to we were applying, in fact, was vertically and crosswise. So we took the first two significant digits, which is the tens place digit, if it was a 2-digit number. Then it was like the first part is 1, and the second part was the crosswise part, which is 2, and the third was again the vertically part. So let us first of all see with an example how it is working. And this example is 72 times 78. This we have tried yesterday, how to do numbers where the first digit is same, but the second digit adds up to 10. Anybody knows what are the steps? Or if you have got the answer, you can just write that down. Mahindra has answered. Yes. So I'll just explain. So if the number has the same tens digit, but the unit digits add up to 10, then there is an easy way to solve this. You multiply these units digits, 2 times 8 to get 16, and you do one more than the one before. So this is a sutra that we have learned yesterday, one more than the one before. So what is one more than the one before of 7? It is 8. So you have to do 8 times 7 to get 56. So the answer is 5616. Okay. Ashraf, can you just check your answer once again? Now, what we are going to do is vertically and crosswise for the same question, 72 times 78. So let us check what is 7 times 7, which is 49. I can write it as it is. The next number is crosswise. What is that? 7 times 8 is 56. Again, plus 14. What is 56? Plus 14. Yeah, it is 70. 70, we have to write it something like this. Again, the last part is 2 times 8, which is 16. 16 is written as it is. Now, you can see how it works. The one more than one before method and this particular method that we are explaining, there is a relationship. The number here in the tens place that is going to appear is always 0. And that is the reason why you could write 16 as it is. And this 7 would carry forth to 49 to give 56. So hope the method now is clear. Okay, somebody is asking to write bigger. Okay, I'll just explain this question once again in some bigger font. So let me just first of all clear all the ink. So I'm going to apply vertically and crosswise. So let me do the first step, which is the vertical step, 7 times 7, which is 49. Then the crosswise step, 7 times 8 is 56 plus 7 times 2, which is 14. So I have to add 56 plus 14, and that would result in what? 70. 70, I will write it as 0 and 7. So hope now it is visible more. Now the last part is 2 times 8, which is 16. 16, I'll write it as 6 and 1. Now I'm going to take 1 as a carry to the next place and 7 as a carry to this place. So the answer is going to be 5616. So I hope it is clear to all of you. Let us go to moving multiplication now. Now this is the last concept that I am going to take. So suppose I want to multiply 4321 times 32. The method that I'll apply is moving multiplication. So I can still apply vertically and crosswise. Since 32 is a moving number, I will just consider which digit it is coinciding with. So here I can do a vertical step and here I can do a crosswise step. So the vertical step would result in what? 12. And the crosswise step is 8 plus 9, which is 17. So this part is going to be what? 137. Again, we'll move this number by one place. So 32 now appears above this numbers 32. In this place, we'll only apply vertically, only crosswise, because vertically is always applied towards the end numbers. So here we'll only apply crosswise. What is this crosswise? 6 plus 6, which is 12. 12, I can write it like this. Now, the last part is 32, now coinciding with the last two numbers, 2 and 1. So this is going to be crosswise first here, and then vertically over here. So 4 plus 3, which is 7, and the last part is going to be 2. So we have to add all these numbers now. What is it? 137, 12, and 72. So 137, 12, and 72. So 72 we'll keep as it is because this is a 2-digit number. So the answer is 138,272. If I'm not mistaken, we have to put 72 as it is. But I can check on this. Can anyone confirm on this? Yeah, 138,272. Yeah, I can see Maunika has confirmed. Ashraf also has confirmed. So if it is a 2-digit number, you are allowed 2 digits over here. So if you do not understand this, I'll explain to you once using this second example over here, 31013. So this is, we are going to do this particular multiplication in a moving fashion. So if this number 21 is going to be on one of the sides, just like this, it is on one extreme side, we have to do a vertically step as well as a crosswise step. So the vertically step would give 6 and the crosswise step would give a 5. What we are doing is 3 into 2 is 6, and we are doing 3 times 1 plus 2 times 1, which is 5. Again, we move to the next part. This is a moving multiplication. So here we have a crosswise only because we are not in the extreme part. So the crosswise step is 1 plus 0, 1 into 1 plus 2 times 0, that is 1. And the next part is what? Again, a crosswise term because we are not in one of the ends. So 0 times 1 plus 2 times 1, which is 2. And again, we have the last part. Here we have to apply vertically as well as crosswise. So 1 times 1 plus 3 times 2, which is 7. And the last part is 3. So the answer is going to be 6, 51273. You can verify this answer. Yeah. So some of you may not have understood this particular moving multiplication. So I want you to go and revise this when you are free after this lecture. So let me just go on to explaining this puzzle for you, which will appear in the Practically app. So do not shout out the answer as soon as you get the answer. Do not use a calculator also. So this time the question is to do a multiplication and then take a square root. So everyone knows what is a square root? If you know what is a square root, kindly put yes, Y in the chat box. Yeah, so most of you know what is a square root. So I'll just give you an example. Square root of 36 is what? I don't see any answer. Suhas says it is 6. Yes. So square root of any number is found out by how many times there is a repetition of the number. So what is the square root of 81? It is 9. And square root of 100 is 10. So what you have to find is square root of this large number that is put here. Now what you want to apply is vertically and crosswise to compute this long multiplication. So this you can do at home and try to figure out whether it is possible to find the square root of this large number. I'll teach you a method to do square root very fast in a future lecture. But for now, I just want you to concentrate on figuring out what is this product. Remember that there is a +1 at the end. Now today's lecture, I want you to expose to a competitive maths question. So this subject of Vedic mathematics is very useful for applying to competitive maths. So when I talk about competitive maths, it is something like if you have heard about Olympiads. Have you heard about Olympiads? Or if you have seen some NTSE or National Talent Search examination. In all these places, you will see Vedic mathematics very useful. So this is a question that is taken from a pre-Olympiad round question. Yes, some of you are posting IMO, so International Maths Olympiad. So this particular question is from a pre-Olympiad question, which appears as a regional round, I think. So this is called as a magic square. Some of you may have heard about magic square, but don't worry if you have not heard. This is all about putting 9 numbers inside a big square like this. So it's a 3 by 3 square inside, and you will have numbers at each of these boxes. Now the magic square just says that you have to add all the numbers in a particular row. You consider the first row, you add all the numbers. Second row, you add the numbers. Third row, you add the numbers. In each of these sum, you will get the same answer. So for example, if the sum of the rows is 120, you will get 120 as a sum for all the other rows as well as columns. So this is a very special square, which is known as a magic square. And also in certain magic squares, you can also get the diagonal. Diagonal is the elements crosswise. So today we learned vertically and crosswise. So if you take numbers in the crosswise direction, that also will sum up to the same number, which is 120. So we are going to see a magic square today. So this is the magic square. But in this magic square, there is an unknown number x. And the whole idea is to figure out whether it is possible to find this unknown x. So what it says is that x plus 19 plus 96, which is a sum, will be true in any row, any column, or along any full diagonals. So today I will not go into the details, but I will show you some numbers appearing in this slide. And this is the procedure how we will go forth. You can try it at home. So these are the sequence of steps you can identify to find out what are the missing numbers. So this is the entire magic square now, but still the x is unknown. But there is a method to solve for x. You add up all the numbers in the diagonal now, which is 3x minus 95 minus 190, which is 3x minus 285. This is same as writing x plus 19 plus 96, which is 115. So if you solve for this particular equation, you will get what is the value of x. So this implies 2x. You can take x to the other side and you will get the number as 285 plus 115, which is 400. So the value of x is 200. Now substitute 200 here. What is the sum of 200 plus 19 plus 96? It is nothing but 315. So the sum of this row is 315. Let us find the sum of this column. 200 plus 1 plus 114. This is also equal to how much? 315. Similarly, you can substitute x equal to 200 here and figure out this number is nothing but what? 115. No, it's 105. And you can figure out that this is also adding up to 315. So that is an exercise that you can do at home. So I would like to conclude today's lecture and I would like to see some of the questions from you. So I'll just take the participant list and I can see a few raised hands now itself. So let me open the floor for questions. First, I will take the question from Tanmay. Tanmay, you can unmute and ask. Tanmay, if you are there, you can unmute and ask. Okay, I think she's not asking. Let us go to Maunika. Maunika, please unmute and ask.
Sir,
Yeah.
can you explain again about magic square?
The last problem.
Yes, sir.
Okay, I'll explain to you.
Thanks, sir.
Let me just go. So, Maunika, you can just tell me what part you did not understand about magic square.
Sir, here's x19, that one. Square only.
Okay, right. So here I have put some numbers in this magic square. So let me just first of all eliminate all this things that I have written here. So currently we are having this unknown number x. The idea is to find what is the unknown number. Since it is a magic square, then addition of numbers in the row. What is the addition of x plus 19 plus 96? It is x plus 115. Similarly, the addition along this column is also 115. Sorry, x plus 115. So this is why it is called as a magic square. If you add it along any row or column, it is going to be 115. Let us take one more example. Consider this particular row. So 1 plus x minus 95 plus 209. So 1 plus 209 is 210. 210 minus 95 is 115. So this is again equal to x plus 115. Understood? So Maunika, have you understood?
Yes, sir.
Okay. So I'll explain more about magic square again when we encounter a puzzle similar to this. Let us go to the next question. Suhas. Suhas, you can unmute.
Sir, before you played a video, sir.
Okay.
Sir,
Was it
sir, it's
audible?
not clear, sir. It's not audible at all.
Oh, it was not audible. I can play the video once again. I can
sir.
play the video once again, or I'll share it in the Practically app. Okay.
Sir, where will you share, sir?
I'll share in the assignment part.
How
So you
to
can see the video in the Practically app itself. Okay. Or if you want, I'll play that towards the end after I take up the questions. Okay.
yes, sir, play after all.
Yeah. Okay. Sure. So
Okay.
Mahendra.
Thank you.
Yes, sir. Yesterday, good morning, sir. Yesterday you said like a puzzle, right, sir? Can you explain? Means like, can you discuss about it? Yesterday's
Okay.
homework puzzle.
Okay. So can you just help me with the question? What was the question yesterday that we had in the puzzle? Can you repeat the question, Mahendra, if you don't mind?
Sir, I don't have it, sir. Now.
Okay. So if I remember it, it is like you had a number like 10,000. So you have to find the factors of 10,000, which are not multiples of 10. So you have to represent 10,000 as some x times y, and x does not have a factor of 10 and y does not have a factor of 10. And then you have to find something like x plus y. So this was the question. So I'll just repeat the question. Some of you may not have understood what I was saying. So there is a number 10,000. 10,000 is made up of a lot of factors. For example, you can write 10,000 as 2 times 5,000. So 2 and 5,000 are factors. But if you see 5,000, this is a multiple of 10. So such factors are not allowed. Then you have to find what are those factors and find the sum of those two. So let us figure out how to do this. So first step is to write 10,000 in terms of prime factorization. Some of you might have learned this in school. If you have not seen this before, I'll explain to you. So 10,000 can be written as 100 square, isn't it? 100 times 100. There are 4 zeros, 100 has 2 zeros. So if you just square it, you will get 10,000. Now 100 is nothing but 4 times 25. This also is known to many of you. 4 is nothing but 2 squared, 2 into 2. That you can write it as 2 squared. And 5 is nothing but 5. So 25 is nothing but 5 squared. So what you're going to get is nothing but, let me just write this clearly. Yeah, 2 squared into 5 squared, the whole square. So the prime factorization of this is 2 to the power of 4 into 5 to the power of 4. Now, when do you get a factor of 10? You get a factor of 10 only if you multiply 2 and 5. So unless you multiply 2 and 5, there is no factor of 10. So the numbers x and y will be these independent factors. So x will be equal to 2 to the power of 4 and y should be equal to 5 to the power of 4. So what is 2 to the power of 4? 2 multiplied 4 times, that is 16. Y is 5 to the power of 4, which is 5 multiplied 4 times. What is that? Or you can do 5 into 5 into 5 into 5. What is that? 625. So the numbers are x and y are 16 and 625. So x plus y has to be what? The sum of that, which is 641. So Mahendra, I'll just unmute you once again. Was this your doubt? Mahendra? Okay, I think I have answered the question. Yeah, time is up actually. So those students who do not have a question to ask may leave. The others can kindly raise their
Yes,
hand.
sir. I understood, sir. This is only my doubt.
Okay, yeah,
Thank
thank
you,
you
sir.
for that. Now I'll go to Rani. Rani has a doubt. So at this point, I would urge all of you, if you want to leave the meeting, you can do so. I'm taking up questions from those who have doubt. So I'll go to Rani. Rani, you can unmute yourself and ask.
Sir,
Yeah, please go ahead.
sir, you explained multiplications in two ways. I not understood second way, sir.
Okay,
Second method.
so tell me two numbers that you would like to multiply.
24 into 36.
Okay, I'll explain. Okay, uh, let me just erase everything that I have written here. So let me just go to this slide over here so that there is no confusion. Yeah, can you repeat the numbers? 24,
24 into 36.
24 into 36. So you want to do by vertically and crosswise. That is a method that we learned today. So I'll explain that first. So first you do multiplication in this vertical manner, 2 times 3, which is 6. For finding out the middle number over here, do multiplication crosswise, which is 2 times 6 plus 3 times 4. What is that? 12 plus 12, which is 24. But 2 is an extra number, so that I'll write that 2 in the subscript. The last part is 4 times 6, which is again 24. So I'll write it as 4 and subscript 2. Now you add the subscripts to the next number because these are carries. So the answer is going to be 864. Is it clear now? Is this method clear? Vertically and crosswise?
Yes, sir. Another method I want, sir.
Okay, you want the other method. I'll explain to you. So this method is being taken from the previous class. Now I want you to find out which is the closest base. You know what is the base of the number? What is the base which is closer
30.
to 24 and 36? Yes, you have answered it correctly. That is 30. Now, how much away is 24 from 30?
6.
Yeah, it is minus 6 because 30 minus 6 is 24. 36 is 6 more than 30. Now, this is a negative number multiplied by a positive number. So, what is it going to be? A negative number, isn't it?
Yes, sir.
So you have to write the product as a bar number now. Bar number means you have to put a dash above the number. So 6 times 6 is 36. So you write it as 36 bar. Now you can do cross addition. Cross addition is 36 minus 6, which is 30. So this is the first part or the left hand side of the answer. But you have to multiply this by 3. Why? Because the considered base is 30, which is 3 times 10. So since we are not dealing with the true base, you have to multiply that factor by which the local base is constructed. And that factor is 3. So the answer here is going to be 9036 bar. This is a bar number. You can convert this into the usual number by writing 9000 minus 36. So what is this? You can do all from 9s, last from 10. This answer is going to be 8, 9. Am I right? Yeah. 8, 9, 6, 3, 6, 4. Have we made some mistake here? Okay, this is 90 and 36. Okay, so actually this 36 is a 2-digit number, so you'll have to be a little bit more careful. So 36 is again a little bit different. So what you can do is what? So if it is a 2-digit number, you can write it as 3 bar and 6. So actually this has to be a carry. So this has to be 90, 3 bar and 6 bar. So this has to be 90 and minus 3, which means it is 876 bar. So that is why you are getting 876 bar as 864. So I think I confused you in the last part. Who was asking the question? Rani. Is it clear? The second method, is it clear? You can unmute and ask.
But minus 6 is there, no, sir. We should minus, no, sir. 6 minus 6. Why you multiplied?
No, this minus 6 times 6. This is multiplication. Last digits has to be multiplied. That was the method that we talked about in numbers close to the base. So for example, I am doing 22 times 24. I know that 22 is plus 2 from 20 and this is plus 4 from 20. So this is going to be 8, which is the product of 2 and 4. So in a similar way, you have to multiply minus 6 and 6. Now you have to be a little bit careful here. I have made a mistake here. This part is a mistake. Here you have to consider 3 as a carry. That is why it becomes 8, 7 and then 6. I'll explain this particular method yet in the next class, because we are going to deal with this kind of multiplications where one number is above the base and one number is below the base.
Okay, sir.
Okay, thank you. So we have question from Maunika.
Sir, now you share one video, right, sir? On that video we can't hear, so can you please again share it?
Okay. I'll just share that video. I think there are no more questions. So this is the last thing I'm going to take. I think Tanmay has some question. Tanmay, you have raised hands. If you have a question, kindly unmute yourself and ask. Okay. So I think Mahendra and Suhas have asked. So Mahendra, what is your doubt again? Is
Yes,
it regarding
sir.
the
Means
video?
like, yeah, sir. Means like you have to share the computer sound, sir, so that
Okay,
we
okay.
can hear.
Okay, let me do that.
Okay, sir. Down option will be there, sir. Like more. If you click that, share computer sound will come.
Okay, let me do that. I'll just share that video. Let me stop sharing the slide first. So please confirm in the chat whether you are able to hear while I play.
I'm going to ask you to do something very pedantic.
The sound is coming.
Connection between tabla
Okay.
and maths. Play 10 seconds on here and show me some connection.
I wish I had tabla here.
Here, just use these to imagine their tablas and then just kind of give us the connection.
Well, these Hemachandra numbers that I was just talking about, longs and short beats,
Right.
all those things get translated when you're playing tabla also. So there are lots of compositions for the tabla where you have, so when you're playing with, say, some sitar player or something, you may be in a part of the piece where there's this dichotomy between long and short.
Right.
And so you'll do improvisations with each other, just passing back and forth long and short combinations. And that's why this Hemachandra idea is very important to tabla players.
Right.
We want to know all the ways that if you're improvising, you have 8 beats of music left, you have to fill it with this motif of the time, which is long versus short. You need to know all those combinations and how they're made so that you can draw from them. So that there's a mathematics of it, which is to know what you have at your disposal. Just like a painter needs to know what kind of colors they have at their disposal.
Yes.
But then there's the artistic aspect. Which ones should I choose from there
Right.
that'll sound the best at that moment? And that's the artistic part of it.
So just show us a long and
So-
short beat, for example.
So one way that on tabla it happens, dhati gina might be a long,
Right.
dina might be short. So-
Okay. Wow. Wow, that's fantastic, isn't it?
So hope you have heard the video. Okay, thank you. I can see a thumbs up from Mahindra. That is nice. So let me just share the screen. Let us see if there are more raised hands. Yeah, Maunika, do you have something to ask now?
No, sir.
Okay, so Mahendra, I hope your question is now cleared. Suhas, do you have anything to ask?
Sir, once can you explain vertical and cross method for 78 into 86?
Okay, 78 into 86. So I'll just do here. First, let me just clear the screen. So at this point, I just wanted to mention, if you don't have any doubts, you may opt out of this video, of this meeting. If you want to stay, you can do so as well. So Suhas has asked us to multiply 78 times 86. Is it correct?
Yes, sir.
Okay. So I'm going to apply vertically and crosswise. So vertically, the first step is 7 times 8, which is 56. Then crosswise, I have to do 7 times 6, which is 42, plus 8 times 8, which is 64. 64 plus 42 is what? 106, isn't it? Okay, so you have to write 106. Okay, so here you have a little bit of difficulty, isn't it? So 6, and there is a 10 here. And the last part is 48. 8 and 4. So you can take like this. This will be 10. So the last part is 8. 4 plus 6 is 10. So you can write 0 and give that 1 back to 10, which is 11. So 11 plus 56 will be what? 67. So is this the answer? I'm not sure whether this is the answer. But I hope it is very close. Is this answer? Actually, you have asked a very good question because this has a lot of carry in them. So I'll just explain to you. I don't know whether the answer is right, but
Yes, sir, it is correct only, sir. But, sir, we have to add 11 to only 6, no, sir. Why are we adding to whole 56?
no. So we are doing single digit wise because these have, we are doing digit by digit multiplication. So the base that we are considering is 10. So each place should have only a single digit. That is why we have this 10 to be carried over to 56.
Okay, sir.
I'll take up more of these kind of examples in the next class. So we have only started with this vertically and crosswise. So I'll take up more complex cases in the next class. But thank you for asking this question also.
Okay, sir.
Sir, somebody asking which lesson is going on.
Okay. Yeah. So what we are looking is currently multiplication. So in Vedic mathematics, we basically deal with methods to make your addition, subtraction, multiplication, and division faster. So this is the first level in which Vedic mathematics we are going to learn. So we have covered addition, subtraction, and multiplication until this class. Next class onwards, we'll deal with the division. So Tanmaya, you have asked that. You are, I think, first time coming to this class. So what you can do is you can go and watch these videos for Vedic Maths class in YouTube. Okay.
Sir, should we have to pay fees, sir?
So I'm not very sure about the fee and all. You can check that in the Practically app. I'm not very sure on that.
Sir, I know it clearly, sir. When we open Practically app, we just go to more option and select virtual sections. There we can see completed classes. There, these all recorded classes are there, sir.
Okay, so Maunika has given you where to check out for the previous lectures. So that, yeah, Maunika, can you just repeat that once again?
So first we open Practically app and select more option, and there we can see virtual sections. We select that, and select that we have to upcoming classes and completed classes. We select completed classes.
Yeah.
When we select completed classes, there we can see all of these classes.
Yeah, so very good. So all the other students can also check these options in the Practically app. So I'll just like to end the session. We have long exceeded the time. Thank you for all students who have stayed back. So we shall meet next Saturday. Thank you and namaste.
Okay, sir. Bye, sir.
Yeah, bye.
Bye, sir. Bye, sir.